Okay, sorry about that. Yeah, so you can sign in here, but that's not super important. You don't need to do that. So this is me, Hayden Brenham. I'm an electrical engineering major. I'm a junior and I work with the Success Nights program. Okay, so I'm gonna go ahead and get started with the first thing. So the first thing I want to review tonight is integration by parts, which is simply kind of, in a sense, the reverse way of doing the product rule, where you're basically just determining in a given integral that you're given a u and a dv. And what you choose, it's up to you to choose which one's u and which one's dv. However, with some integrations, it matters which one you choose. With other ones, it doesn't, but you have to be aware of that. And you just follow the that you set up to integrate the equation. And hopefully the goal is to set it up into a more, an easier setup to integrate and get a solution. So I have two examples right here that I'm going to go over real quickly. Let me just switch cameras real quick. Okay. You guys can see this okay?
Yeah, we can see it.
Okay. So looking at this, I see that we have a 7t and a sine of 19t. Now, if I think about the derivatives and integrals of these two parts, this, when I take the derivative of this, that's going to give me a 7t, and if I have to do it again, that's going to be a 0. So this will eventually disappear. This thing here, when I take the derivative of this, that's going to give me a cosine, and if I take the derivative of that, I'm going to get a sine, and then cosine and sine and sine. It's just going to go back and forth over and over again. So usually how you want to set this up is you want your dv to be something that isn't going to change, or that could change, but will never go away no matter how many times you integrate or take the derivative. Well, you want your u to be something that will go away or become simpler if you take the derivative of it. So now that I know that u is going to be 7t and dv is going to be the sine of 19t, I just have to take the derivative. For this du, it's going to just be 7 dt. This one, I guess there's a dt here as well. And then this one I integrate, and I get that v is going to equal, when we take the integral of this, that's going to be a cosine of 19t. But when you do cosine to sine, you should have a negative. And then also there would have been this 19 would have been multiplied out. So there must have been a 1 over 19 beforehand. Okay. So then now that we have our u and our v, our dv du, I can just use the equation I had before, which was u times v minus the integral of v du. So that means this could be a 7t. I'm going to put the negative here. Cosine of 19t 1 over 19 minus, so that's going to be the integral of negative cosine of 19t 1 over 19 times du, which is going to be 7 dt. Okay. And from there, you can look at this. And this part's, we have the integral of that, so that's good. And then this now, 7 over 19, that's just an integral, or that's just a constant. So we can just move that out. So that just leaves us with the cosine of 19t, which is pretty easy to integrate. And Yeah, so but I think from there, you guys can figure it out. I think the main thing to figure out here is just how to set up which one's v, which one's u. So we're going to move on to the next question. If you want me to keep going with this one, you can speak up, but otherwise, just going to move on ahead. So this one, t to the exponential to negative 3t. So when I look at this, I think again, which one would disappear if I kept taking the derivative of it, and which one would always stay? So this one, when I look at the e to the negative 3t, I know that the derivative of e is going to still be e to something. And that's going to be e to something if I take the derivative again, and on and on and on. So this one, I'm going to make my dv, because it's always going to stay there. And this t, I'm going to make my u, because if I take the derivative of that, that just becomes 1. So again, we have the dv equals e to the negative 3t. So that means our v is probably going to be, it's going to be negative 1/3 e to the negative 3t. And then we have our u, which is t, du, which is just going to be dt, or 1 dt. Right. So now plugging this in, we're going to have our u times v, so that's t negative 1/3 e to the negative 3t, minus the integral of v, negative 1/3 e to the negative 3t dt times du. But du is just 1, so I'll say it's the same. And then from there, this is much easier to take the integral of. This is just going to be e to negative 3t. Again, a negative 1/3, so that would be 1/9. So that's going to be negative t to the 1/3 e to the negative 3 minus 1/9 e to the negative 3t. Okay. Okay. Any questions or anything else about integration by parts before I move on to the next part? Okay, sure. So I'm just going to move on to the next part. I'm going to try and go through a lot of these things kind of quickly so we can get as much problems in before your guys' exam. So yeah, okay, so this was the next one. I found this table. I'm going to be honest with you, I found this table by Googling it. So I'm sure you guys can find it if you just look it up. But this table here is super helpful. It kind of gives you a lot of different, the different rules in doing partial fraction. And basically partial fraction, kind of like the integration by parts, is kind of just used to take into something we're trying to integrate and breaking it down into something simpler that is easier to integrate. So I'm going to just let you look at this table for a second. But this is just shows the different kind of rules and properties that how it will change depending on what your denominator is. I wouldn't really pay attention much to what's in the numerator, just to, right? Yeah, I just look more into the denominator of the problem, and that kind of lets you know how you should break up your problem. Okay. So I'm going to go ahead and do some more example problems. Welcome, James. Just how you joined in. Anyway, so I'm just going to go ahead and do some example real quick. So here we have a 1 over x plus 6 and x minus 2. And, you know, looking at that table, I know that this can just be broken up, so I'm just going to rewrite this. 1 over x plus 6, x minus 2. This can be broken down to an a over x plus 6 plus a b over x minus 2. Right. So the easiest thing you could do is you can just solve for a and b using this equation, right? Because we know if we were to combine these together, what we would get on top has to equal 1. So the way I would do it in this particular situation is I would multiply this times a, this times b, just as you would if you were trying to combine two fractions together. So that would be an a times x minus 2 plus b times x plus 6 equals 1. Okay. Now we can add it out, so we have ax minus 2a plus bx plus b6 equals 1. So you can notice on this side there isn't any there isn't any x's on the right hand side. So that means all these x terms, ax plus bx, have to equal 0. And you can just bring out the x. So we know that a plus b has to equal 0. Well, kind of similar with the other terms, we know that this term and this term added together has to equal 1. So we know negative a times 2 plus b times 6 has to equal 1. And I know from this first equation that a is going to have to equal negative b. So I can just substitute that into this equation. So that's going to be b times 2. The negatives would cancel out. Plus b times 6 equals 1. So that must mean that b equals 1 over 8. And then since we know a is equal to negative b, we know a must be equal 1 to negative 1 over 8. And then taking that back to our original equation, we would get that a negative 1 over 8 over x plus 6 plus 1 over 8 over x minus 2. Oh, sorry, you're not seeing that. There we go. Okay. And then from there, this is still being taken as an integral, right? From there, we could integrate a lot easier. But I'm going to save that. Unless you guys want me to go over how to integrate this, you can ask me to, but I think from here you guys you understand how to do that. So I'm going to go ahead and move on to the next problem.
I have a question.
Yes.
So my professor told me if you do a over x plus 6, you can just pick an x value. So you set that x value equal to 0. So it'd be a over negative 6 plus 6. And then you can just solve for b. So I ended up getting b equals negative 8 and a equals 8. And yeah, that was the way he explained it to me.
Okay. Did you mean... Sorry, say that one more time.
All right, so he said you pick two, or you can pick an x value that sets the denominator equal to 0. So if you're trying to solve for b, you want to have the denominator for a equal to 0. So
would that get you, sorry, would that get you something like this, where it's 1 over negative 8 times x plus 6 plus 1 over 8 times x plus minus 2?
Yeah, so I don't know. I mean, the way he explained it was you just set the denominator. I can't see the bottom of.
Oh, oops. There we go. Sorry, I have to keep speaking. It keeps shifting as I don't have it. I have to change that. But Oh, yeah, so I meant something. Would it give you something like this?
When you solve it out entirely,
Yes.
I haven't solved it out entirely yet, but I can see.
Okay, well, so I got these problems from a tutoring thing on, actually, I might put a link for that for you guys in this description. I'll do that at the end, but there is a tutoring worksheet that has a ton of practice problems for all of Calc 2. So that's where I'm getting all of these problems from.
Okay.
And that was the solutions on the worksheet. And this is kind of how I've understood to do this, right?
Yeah.
Because if this is true, right? If I wanted to combine, here, let me grab another paper. Because the way you can test if it's true is you try and get the original equation back, right?
Yeah.
So -1/8 over x plus 6 plus, okay, I made that a little big, but whatever, over x minus 2. So if I want to get the original equation back, right, I would combine these together, right? So I'd multiply this by an x minus 2, multiply this by an x minus 2, multiply this by an x plus 6, multiply this by an x plus 6, right? And now since these are the same, they can combine together. So that's going to be a -1/8 x minus 1/4 plus 1/8 x plus 3/4, right? Right. Oh, that would be plus, my bad. So it would be -1/8 x plus 1/4 plus 1/8 x plus 3/8 over x plus 6 times x minus 2. And when you add these all out, that cancels with that. And 1/4, oh, sorry, that should be a 4. This should be 3/4. Okay. So that's going to be 1/4 plus 3/4 is going to be 1 over x plus 6 over x minus 2. All right. So I got my original back, so I'm pretty sure these values I calculated are right. But that's the way you can use to test your thing. But I don't know, I think what you were saying is right. It's just a different method than the way I was taught and the way I understood it.
Okay, yeah, I actually see where I went wrong.
Okay.
You're supposed to multiply, so like for under A, I would also have to do x plus 6 and x minus 2.
Okay.
Yeah, so that's, thank you.
No problem. Yeah, and I guess kind of a side note on all of this is there's always a lot of these things have multiple different methods on how you would approach them. So I might be doing things a method different than the way your professors have taught them. So if that's the case, don't be afraid to like speak up and be like, wait. So, and so whatever method your professor is teaching is probably the best way. This is just the way I've understood it. And I might also be using some shortcuts that I've picked up as well over the years. But yeah, so I'm gonna go ahead and move on. If there's not any other questions, I'm gonna go ahead and move on to the next one. So the next one, I don't think I can go back. So the next one is gonna be to find an area between two curves or two lines, right, on a graph. So I have these two equations here, and I want to find the area between these two, all right? And so the method that you would use to solve this, well, first of all, you need to kind of figure out which graph, how they kind of look. And your best method of doing this is to graph them. And you have your graphing calculators are usually allowed on a test. If you're doing homework, I would recommend Desmos. It's pretty great. But on an exam, you can use your graphing calculator to get something along these lines. So when I graph these two, I'm going to go ahead and see that that the first graph, the 7x minus x squared, is going to look something like this. Well, the second graph, this y equals 2x, is going to look something like this. So when it says to find the area between the two curves, it must be talking about this area. And so it's pretty easy. Once you have identified that, the equation that you're kind of given is that you take the integral of the top part, sorry, not the first part, the top part, which would be our, I'm going to do this, 7x minus x squared minus the bottom part. So that would be minus 2x dx, okay? And then you need these boundaries though. So I'm gonna look at it, you could do this in multiple ways in terms of x and y, but I'm doing it in terms of x. I'm gonna look for the x value here and the x value here, because this is kind of like the beginning and the end. So this point here, well, that's going to be easy. That's just 0, 0. But this one here is going to be a little bit harder to figure out. But luckily what you can do is you can just set your two equations equal to each other. All right. And then whenever values of x that work in this equation will give you the right values. Now looking at this, I can see, well, if x equals 0, that would work because then I'd have a 0 and 0 on both sides. So that must be this point. But there might be another point. So that's why I'm going to divide by x, get 7 minus x equals 2. And then solving for x, I'm going to get x equals 5. Right? So that's probably this point. So this point here is probably 5. And if you plug it into either equation, you're going to get a 10. So that's the point. These are the 2 points the lines intercept each other. So I'm just taking the x values though. So we're going to go from 0 to 5, right? And then from here, it's pretty straightforward. So we know if it's 0 to 5. Doing all that out, we get a 5x minus x squared dx, which we know that's going to be originally an x squared. Oh yeah, so it's going to be a 5 over 2 minus a 1/3 x cubed. And then we're going to plug in the values from 5 to 0. And I'll spare you guys all the arithmetic, and I'll just tell you that it's going to be 125 over 6, or about 20.8. Yep. Okay. Any questions? Okay. Okay, so now that one is when we're just trying to find an area. And area is two-dimensional. But they decided that they really want to make things a little bit more difficult and give us a problem like this, where they're searching for the area, the third dimensional, or the volume of a certain shape rotating around an axis. So let me show you. So, for example, like this, right? So they're giving you a certain line, a function, and they want to know if you took that function and you rotate it around either the x or the y axis, they want to know that area. And when you're given a problem like this, there's kind of two different ways that you can solve it. You can either do something called disk, where you break it up into a whole bunch of disk. And basically what you're doing is it's like you're taking this third dimensional shape and you're slicing it up into a whole bunch of just disk, circular disk, right? And when you do an integral, you're actually doing a sum of all of these disks together. So that's the first way you can do it. Or the second way you can do it is doing what we call shells, which I have another problem for that if we want to go over too, but shells is where you're basically taking the circumference and multiplying it by this kind of like a surface of that shell, but over and over again at different levels and combining it all together. So maybe it's better shown than said, but here I have a problem where they've given me, is that camera kind of out of focus? Are you guys able to see it? Okay, it's looking a little blurry from my monitor.
Looks fine.
Looks fine? Okay, sorry about that. I was just, okay, sorry. Anyway, so I have these equations here that are given to me. And they want to know the volume that this area of these curves all together would create. They want that area rotated around the y-axis, and they want us to solve it using disk. All right. So once again, it's usually good to graph this out to get a visual idea of what we're looking for. Graphing calculators are great, or you can also change this formula since we're giving it in terms of y. You can solve for y and graph it that way if that's easier. But ultimately, what you're going to get is you're going to get a curve like this. Oh, excuse my terrible hand drawing. You're going to get a curve like that. And then you have your y equals 3. So you're going to have a curve like that. Zero, which is just, so it's talking about this. And it wants us to take this area and rotate it around the y-axis. So it's going to make like a weird kind of circular bowl shape that's filled. It's kind of what it will look like when it's all done. And it wants us to do it in terms of disk. And so the way I see it is, when you look at it from this way, if I was to take a slice this way, right, along the, in the y direction, right? If I was to take a slice like right here of the whole thing, once it's been rotated around, that would be like a disk, right? Well, and the disk is circular shaped, and we know that the area of a circle is pi r squared. And so the equation that we use for this is you have this kind of radius thing, which is this here. I'll call this r. So r is a function usually, so that's probably something along these lines. But usually it's that function. So I have a pi out here. That I'll call that function squared. So that's like your r squared with the pi out front. And then these boundaries is going to be the beginning point of the disk and the ending point of the disk. So if I was to keep chopping these up like this at the very end, the last disk I would chop up would be here, and the first disk I would chop up would be here, right? So these are our boundaries from here to here in our y direction, right? So I'm going to look at this, and I see this one here, and I see this radius, and I think, well, that radius, this length here, that is the same thing as this 6 radical 3y, right? Because that's this curve right here. So I can just plug that in to right there. And this is your radius. Okay, well, in this point here, that's just 0, 0, 0, right? This point here is 0, 3. And we know that because we have our equals 3. Here, direction is going to be 0 to 3. So with all of that set up, we can then write the equation from 0 to 3 squared dy. And the reason why it's a dy is, well, first of all, it's because we're doing this in terms of y. But the other reason you can think of it too is each disk that you're adding together has like a little bit of thickness. Like if I was to zoom in on this disk that we're taking the slice from, it has this thickness dy. And so it's kind of like this is third dimensional, except dy is an infinitely small number. But basically what we're doing is we're zooming in, we're multiplying by that tiny thickness, and then we're taking the sum of all of these disks together. All right. So then when I simplify this out a little bit, 0, 3. So I'm going to square everything. So that's the dy will still be there. Okay, well that's pretty simple because this together is just 108. And we just have a y and a dy. So writing this out even simpler, 0 to 3, that's just going to be 108y dy. That's pretty easy to take the integral of. That's just going to be pi times 54 y squared. Once I take the integral, evaluated from 3 to 0, which is just going to be 486 pi. Okay, any questions? Okay, I'm just going to go back. PowerPoint real quick. Okay, yeah, so that's the problem there. So I also have another problem of doing shells, but because time is kind of going by pretty quickly here, I think I'm going to go ahead and just move on to the series and sequences, and if we get on to the next part, I'll cover it. Okay, so series and sequences. So there's a lot of different tests with these. I'm sure your professors have given you a lot of different tests. There's like the ratio test, I think, and the root test and all this sorts of stuff. And I don't really have time to go over it all together, but I think just these simple concepts here will definitely help out a lot. Is if you're dealing with a sequence and the limit and if you're taking the limit as n goes to infinity, that should be as n goes to infinity. In the sequence, if you take that limit and it's a finite number, then the sequence, okay, that's just a sequence, not series. Sorry, there's a lot of typos in there. This is that the sequence will be convergent, right? But series, it's a little bit of a different story, where if the limit of the sum goes to 0, then that series will be convergent. If the limit does not exist, or if it does not go to 0, it's going to be divergent. Okay. And again, there's a lot of different tests with different things that you're given. But I think if you kind of understand those two ideas, that helps a lot in understanding these two things. Like, for example, I have this problem of n minus 1 over 8n minus 1. I'm just going to grab that. Okay. All right. So the first part of the problem was just this. I'm going to ignore the series for now. Where it gives me this a of n equals n minus 1 over 8n minus 1. And then the limit as n goes to, this is if we're testing the sequence, right? So I'm just taking this as a sequence, not as a limit, right? Minus 1 for 8n minus 1. Okay. So the main kind of a trick here that can help is there is a certain test you can do, but when I look at this, I kind of think of n not like as infinity, but as like a really, really big number, right? And as that number becomes really, really big and goes to infinity, this -1 here, or that -1, it's not really going to make much difference, right? It's going to be such a tiny difference that the bigger and bigger n becomes, it becomes basically non-existent, right? So usually the trick is if you're taking the limit as something goes to infinity and you have a numerator and a denominator, you can kind of just take the part that has the highest power, this part that has the highest power, and you can kind of just drop everything else. So that would be n over 8 over 8n. And that's just because as n becomes so big that the rest of these values are just going to be so small in comparison, it won't matter. And then here we're just given, it's just simple arithmetic, the n's cancel out, get 1 over 8. Right? So we know the limit of this series as n goes to infinity can be 1 over 8. Kind of a counter example is if like you had n squared plus 4 over n, let's say to the 4th plus n squared plus 2. You would have, if you were given this, you would just look at the highest power, bottom, and then you would just kind of ignore everything else. Well, okay, so this can cancel out with 2 of these, but you're left with 1 over n squared. And as n goes to infinity, that's basically 1 over infinity, which is 0, right? Or an extreme, and a number so small, it's basically 0, right? So that's one trick there that can help you out a lot and kind of get you an idea of how things kind of work. Okay, so that's for, taking limits, but that's also for looking at series, right? Or sorry, sequences. Now we want to look at this series. So we first need to test, is this series going to be convergent? And convergent means that that this whole thing is going to equal a finite number, right? If it's divergent, that means it's going to be infinite or unreal, or it's not going to exist. So let's test divergent test. So I have a divergence test here. I didn't write down the name of this convergence test, but I'm sure you guys will know as soon as I write it. Right, so you have this divergent test. And I believe that in order for this to be true, this has to be less than 1 for it to be convergent. So I just take this, and this whole thing here, this equals our a of n. So what I'm going to do is I'm going to do the first a of n plus 1, right? So I'm just going to take all these terms. Wait. Oh, wait. No, I'm wrong. That's powers series. Well, you could do that test, but there's actually an easier way of doing that. I'm going to save you guys some trouble. So if you look at this, you can actually just take the you can just take this part from before. If you take this, the limit as n goes to infinity, a of n. So we know that equals 1 of 8. So the actual rule for the series is as you take the limit of this has to equal 0. Ignore this part. I was getting things mixed up with the previous note. Yeah, you're right. It does diverge. Yeah, so because this does not equal 0, this is divergent. Sorry about that. I got some things mixed up there, but yeah. So just because that's not equal to 0, it's divergent. Because if you think about it, this is going to, as n becomes infinite, you're going to get a 1 over 8 plus a 1 over 8 plus a 1 over 8. Because these numbers, when they become so big, well, you'd have numbers before that, but you're eventually just going to get an infinite number of 1 plus 8 plus 1 plus 8. And that's going to be that's just going to be infinity. Oh, sorry. So yeah, so that's just going to be equal to infinity. Okay. Okay. Any other questions or thoughts before maybe I move on? No? Okay. So, okay. Okay, so then we got power series, and this is what I was meant before with this test. But so let's say, for example, you're given this problem. Find the largest open interval of convergence of the series and the radius of convergence for this. So this thing, you know, looking at it, it's kind of ugly looking, to be honest, but there is a way we can break this down pretty easily. So I have a copy here. So this is where that previous part was coming from. So if I take the limit, n goes to infinity, so that's where this test comes in. Okay, let's say, no. Wait, yeah. Sorry. A of n plus 1. That's, okay. Limit, let me just write this over. A of n plus 1 over a of n. There we go. If this is less than 1, then we can say that this will be divergent, or this will be converging, if this is true, right? So this is our condition. So I'm going to go ahead and plug in our values. So that's going to be an n plus 1. So I'm going to do this first part, a of n plus 1. N plus 1 factorial, because that's what it was before. 2 of x minus 1. I think this is supposed to happen. To the n plus 1. All right. Divided by, so now I'm going to do the original a of n, which is n factorial, 2x minus 1 to the n. Well, so the nice thing here is with factorials, right? You have an n plus 1. So that's going to be, this is the same thing as n plus 1 times n minus 1 times n minus 2, yada, 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 until it gets to 0. And this bottom one, that's going to be n times n minus 1 times n minus 2, yada, 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 until it reaches 0. So the nice thing about this is all of these terms basically will cancel out with nearly all of these terms, right? So this n right here, that's going to cancel out that, and that's just going to give us an n plus 1 on top. Right? And kind of the same thing here, because we know this n plus 1 here, that can just be broken up to, oh, sorry, that should be next here. That could just be broken up as 2x minus 1 to the n times 2x minus 1. So basically, this can cancel with this, and that can leave us with 2x minus 1, right? So then we're given as the limit as n goes to infinity, n plus 1 times 2x minus 1. This has to be less than 1, right? And I'm going to take the limit. So n plus 1, that's infinity, right? So we're given this infinite value times 2x minus 1 less than 1, right? So this infinite value is so large that it kind of looks like at first there's no values here, right? However, if we think about it, there is a values, but because we're looking for values of x that will let this be true, that will let these conditions be true. And there's only one value in this case, because we know any number, even if it's infinity, times 0 is going to be 0. And 0 is less than 1. So if 2x minus 1 equals 0, so then that's 2x equals 1, so that's x equals 1/2. Right? So the values that we have that will work is 1/2. And that's what we would call, but the one condition here is that this is the only value that this would work. Any other value of x, and we're going to get, and this condition will be divergent. Okay. So our interval of convergence is only going to be 1/2. And since that's the only value in which that is true, that means there's no okay. So sorry, I know that was a little rushed. But if there's any other questions or anything else about it that you want to go over. Okay, so I'm gonna go back real quick. Okay, so I have one more power series here. One more thing I want to go over real quick. And this is more of moving around in the other direction. So we're given this power series, or we're given this function, and we want to represent it as a power series. And we're also given this other formula down here. All right, I wrote that up right here. So we're given this formula. So we're going to use this to represent this, right? So first thing first, I'm going to look at this. So we have a 1 minus x, and I'm going to look at this. X squared, 1 minus 3x squared. And I see here in this equation, this is this x to the n. This x is from this part of the equation, right? Well, when I look at this x here, and I look at here, and I look at this part, I see that this part is no longer an x, but instead it's a 3x squared. So I can go ahead and just put that into this part, right? So if we have the sum, right, as n equals 0, that would be 1 minus 1 minus 3x squared, right? Oh wait, no, that's bad. It should be this. It would be 3x squared to the n equals 1 over 1 minus 3x squared. Sorry about that. Think about that. Right? So basically what I'm doing is I'm taking this x value here, and I'm replacing it with a 3x squared, so as to get a 3x squared on the bottom. But that's still not the equation we want, because this equation here has an x squared on top. This one does not. Well, luckily, as long as it doesn't contain an n in it, this series here, it kind of works, what's the word I'm trying to look for? Associatively, where you can take values in and out of it, even if it's x, just as long as there's no n in it, right? So if I had an x squared out here on this side, okay, so n equals 0 to the infinity, 3x squared to the n, it would be like multiplying it on the other side. So I'd multiply this by x squared, but that would just be an x squared on top, 1 minus 3x squared. Okay. And the neat thing about this is this can go inside of here. I'm just going to separate this out. So that's 3n to the x of 2n. I just multiply that out. And then when we add this x squared, that's going to become 3n x to the 2n plus 2. Right? And that would equal our x squared over 1 minus 3x squared. Right? And so that is the answer that we're looking for. That is the way we can represent this as like a power series. Okay. So as for now, that is all of the main problems I wanted to cover tonight. However, since there's still some time, if you guys want, answer any questions to you guys as from the tutoring center, and I can try and do problems from there, whatever you guys would want to do. And I'm going to go ahead and I'm going to get you guys. Yeah, so any questions though about anything we've covered? Okay. Okay, well, if you guys, okay. We do another partial fraction decomposition problem. Yes, we can do that. We can do that, James. Yeah, of course. Let me, sorry, I'm trying to get, oh, there it is. I'm opening up the website. I'm going to link it into the chat here real quick. Okay, so that website, if you scroll down, there is a MAT 266 final exam review. And that's where I got all of these problems from and all my solutions I got from this. I can confidently say that if you know how to do all the problems on here, you will definitely be prepared for your exam. But I'm going to go ahead and I'm going to choose, you said partial fraction, right? Can we do, yes, partial fraction, okay. So I'm going to go ahead and I'm just going to choose a partial fraction problem from here. Let's see, I'm looking for one we didn't do. Okay, this is a good one. Yeah, so let me grab a piece of paper. So I'm going to do, on the worksheet, it's problem number 21. Number 21. And it's x minus 8 over x squared minus 7 x plus 10. All right? So when I look at this, I'm immediately going to look at the denominator. And I see this x squared minus 7x plus 10. And I'm going to say, okay, well, let me try and factor this first, right? And I don't know the factor off the top of my head, but that's going to be negative b plus or minus square root of b squared, which is 49, minus 4 times a, which is 1 times c, which is 10, over 2. And so that's going to be 7 plus or minus. That's 49 minus 40. So that's going to be 9. So that's going to be 3 over 2. So that means x is going to be equal to 2 and 5, right? So this can be factored. This can be changed as x minus 8 over x minus 5 x minus 2, because it's always going to be, the sign is always going to be the opposite of what you have here, right? Sorry, I ran through that a little quickly, but basically what I just did is I just factored the denominator into 2 parts. Now, if you were given a problem, just as a side note, that was not factorable, that if it was not possible to break it up into 2 parts, you would have to slightly do the thing a little differently. And that's why I gave you guys this table, or I showed you guys this table. Let me just find it real quick. That's why I showed you guys this table. Now this one luckily was able to be factored, and the factors are not a square, they're 2 separate factors that are different. So we can just assume just a normal a and b. But if you were given a situation where it was unfactorable or it was like squared or something, you would have to change how you do this a little bit. Okay, but anyway, this is what we got now. So we can assume that this thing could be an a over an x minus 5 plus a b for an x minus 2, right? So, and that equals, that's obviously going to be equal to x minus 8 over x minus 5 times x minus 2. So obviously, what we can just do is, like we said before, I'm going to just do my trick of multiplying these out together. Now, and do be careful that you don't always just do crisscross. That's not always the case. But in this case, if I wanted to combine these two together, I would multiply this by x minus 5, and this times x minus 2 times x minus 2, right? And then the denominators would match, and we can just ignore the denominators on all sides. And so we would get an a times x minus 2 plus a b times x minus 5 equals x minus 8, right? Because since they all have the same denominator, I can just ignore the denominator now. That's going to leave us an ax minus 2a plus bx minus 5b equals x minus 8. So what I'm going to just do is I'm just going to look first at the x terms. And I see here on the right, all the x terms has to equal 1x. And on the left, so we have the a plus b. And I'm just looking at the a here and the a here. Oh, you can't even see this. So I'm looking at the a here, the a here, and the b here. These two together, a plus b, has to equal 1, so that we get a 1 in front of the x here. And then I look here and I see this negative 2a plus minus 5b. That has to equal negative 8. Right? If these two conditions are not true, then it won't be able to break this up. So then I know that b has to equal 1 minus a. So I can just take that and put that in the other equation. So that's going to be negative 2a minus 5 times 1 minus a equals negative 8. I'm running out of paper. I might have to grab another one. Right? So that would be negative 2a minus 5 plus 5a equals negative 8. And then that's going to be 3a minus 5 equals negative 8. 3a is, I'm going to add that 5 over. Negative 3a has to equal negative 1. Right? And since we know b equals 1 minus a, that's going to be 1 minus negative 1. So that's going to be 1 plus 1. B has to equal 2. Right? So taking this original thing down here, we know that a has to be a negative 1 over x minus 5 plus b, which is 2, over x minus 2. So now we have successfully, oh, you can't even see that. Okay. I've successfully broken those up into 2 separate equations. Yeah. And again, your professor might have solved this a different way. Yeah, your professor might have a different technique. Well, slightly different. This is just the way that my professor taught it and the way that I understand it. I think that this works.
Sure.
Yes.
Thanks, man.
So, okay, if that's all, if you're good, then great. If you want me to go over anything else, I'm still free for a little while. But if not, you feel free to go.
That's all right. I'll let you go, but thanks a bunch for this. Yeah. Have a good night.
Okay, thank you.